Hello. Hi, I'm Godfrey. Thank you for coming on a beautiful summer day. Looks pretty nice outside. So if you would like to catch some sunlight, this is your last chance to get out. Um, yeah, sorry. So thank you all for showing up. I know it's tempting to be outside. Uh, and I apologize in advance if I'm not super rehearsed because I just drove up here from Seattle. Literally just parked my car and walked here and like, am I going to make it? Got it, 6:45. Nailed it. We kind of planned this because I was in Seattle for TC49. That's the JavaScript language committee this week. Um, I know you're Ruby programmers, but you probably have to write JavaScript more like for, yeah, you probably have to write some amount of JavaScript for to do stuff on the web. So might as well make it good. And TC49 is where that happens. And I talked to Philip about this. Like it's going to be pretty tight. I don't know. Maybe I will get detained at the border or something. But if we said if that happens, you can watch a recorded version of this talk. But for better or worse, I made it. So now you're stuck with the unrehearsed version. So yeah, that's about it. So let's get, oh, one more thing, I guess. We did, I originally wrote this talk together with my coworkers. They couldn't make it, so just me. But we did this talk at RailsConf. I work for a company called Tilda. We make a product called Skylight. It's a Rails performance profiler. So if you have a Rails app, you can try installing that, and it will show you what's slow, what needs work, and that kind of stuff. There is a secret link on there. I was supposed to take it down, but I forgot. So if you want to sign up with, I think, a $50 promo code, that's probably your last chance. Like, do it this weekend. This is what the product looks like, right? So this is Skylight, instrumenting Skylight itself. But once you basically just gem install, well, you add gem Skylight to your gem file, bundle install, deploy it, and then you start seeing things like this. So it tells you which of your controller endpoints are, if you were to work on performance, which of those are going to give you the best bang for your buck. And when you click into it, it'll show you which part of it specifically is slow, so you can maybe fine tune your database queries and stuff like that. So give it a shot if you haven't seen it, but otherwise I think that's all I have to say about Skylight. So today's talk, right? So who here has used Rails before? Almost most of you, that's great. So as a Rails developer, you're probably pretty familiar with code like this, right? Like, so you would write a controller file in your app/controllers folder, right? Like, and you would maybe write an action def index here. And in the spot where I had a comment, you can basically it's just Ruby at that point, right? Like, you can write any Ruby code you want there. Rails throw in some nice things as well, like templates, but you could just write, you could use your arrays or your hash, your .each, .map, whatever. You can write Ruby code there and it runs, right? Like, and it shows it in your browser. So that's pretty great. But have you thought about how did we get here in the first place, right? Like, all you did is you write this Ruby file, you run Rails S, and then you go to localhost 3000 or skylight.io/hello, and it runs this code right here. But who calls your index method here? Like, who's calling the index action? How does typing URL in your browser translate to this code being run with the right params and everything? And how does the content you render get sent back to the browser, right? So that's what this talk is going to be about. So forget about HTTP, forget about Rails web servers for a second. So let's just say you're trying to meet someone for lunch, right? Like maybe you have a friend in town, you want to meet them up for lunch tomorrow. So you might say something like that, like, oh, let's meet at the restaurant Capostini. That would probably work for your coworkers who goes there with you a lot, right? Who immediately know what Pastini is and where it is and how to get to it. But for your out of town friend, that's probably not super helpful, because your friend who's from out of town, who's not familiar with the area, probably doesn't know what Pastini is or where it is or how to get to it. So instead, you probably want to instead of giving them the name of the restaurant, you probably want to give them the street address instead, right? Like, so that way they can just look it up on Google Maps, or they can just give it to the cab driver and who can take them there, or they can just ask for direction from someone on the street, right? So computers are pretty similar. When you open your browser and you type skylight.io in the address bar, that's great. That's easy for you to remember. I can just tell you our website is at skylight.io, and if I keep saying it, you'll probably eventually remember it, and tonight you can just go there, right? Like, but skylight.io, even though it's easy for humans to remember, it doesn't help your computer to get there. It's kind of like Pastini, right? Like, where is that to the computer? That doesn't mean anything. So when you type skylight.io/hello in your browser's address bar, the first thing that happens is that the computer, your laptop, your phone, or whatever, has to figure out how to connect to your server, like, or my server in this case, running in the cloud somewhere. And to figure out how to connect to my server, figure out how to get to that server on the internet, they need to translate this human name into an address that could help them figure out how to get there. And for a computer, the address they need is an IP address. So yeah, so what they're going to do is they're going to resolve skylight.io into an IP address that looks like that. You might have seen it before when you configure a router or something like that. But yeah, so that's what the computer needs to figure out how to connect to the server. And with this kind of address, the computer can figure out how to navigate through the interconnected network of like routers and cables and stuff to get to my server on the internet. So that system that helps your computer resolve Scala.io or example.com or what have you into the IP address is called the DNS system. It stands for domain name system, right? So the act of resolving that name into the IP address is called DNS lookup. So you can actually try that yourself on a computer. If you have a Mac or Linux computer, you might have a program on your computer called dig. If you're running Windows, you probably have the equivalent program, but called something else. So what you would do is you would type dig scala.io on your computer, and you get an output that looks like this. It might look a little bit intimidating, but the main thing to pay attention to here is that, among other things, it translated the Scala.io address into 34.194.84.73. So that means something to the computer, and that is great. That's helpful. So the DNS system is basically a big registry that stores these kind of mapping from domain name to IP addresses. And when you buy a domain name on GoDaddy or something, not a sponsor, but if you go to, I should probably have a promo code for it, but if you go to GoDaddy and buy Scala.io or myawesomedomain.com, right? Like, you are responsible to register that your domain name maps to whatever IP address that your server is running on. Otherwise, your customer can't find you, and that's not good for business. So, okay, once the computer or the browser have obtained the IP address of the server, our browser can connect to the server that's running on that IP address. you can think of opening a connection to the server. On the other hand, it's kind of like picking up a phone and dialing a phone number. So in fact, why don't we try it? So there is another program on your computer called Telnet. So that Telnet lets you open a raw connection, so to speak, to any IP address on the internet. So that's pretty cool. Here we type Telnet 34.194.84.73. That's the IP address we got from the previous step. 80 is the port number, which is a default port number for HTTP, right? Like the port number just means it's just a way for a single IP address to handle multiple different kinds of connections on the same server. So you get a little bit more bang out of your buck, but for the most part, we're talking about HTTP here, and usually the default port is 80. So here, after we type that, it said that it connected to the server on the other hand, and now it's like kind of like you pick up a phone, you dial a phone number, and it went through. So now someone has to say something, but who is going to say what? Like, what do we say, right? Like, do we say hi? Maybe that works. Unfortunately, that's not what you're supposed to say. And just like when you get a spam call, if you don't understand what they're talking about, or if that doesn't interest you, you probably hang up, and that's what's happening here. The remote server hung up on us because it couldn't understand us. So we need to say something that the remote server, in this case, the server I'm running on the internet, could understand. So what do we say? Let's try this again. The browser and the server, in order for them to communicate, the browser and the server have to agree on a common language that they speak, so that they can talk to each other and understand each other. So that's where HTTP comes in. You probably heard of the acronym a bunch of times, and it stands for Hypertext Transfer Protocol. That's basically the language that both the browser and your web server understand, so they can ask for things from each other. So let's try that from our Telnet. So again, we reopen the connection. So we pick up a phone, got a phone number, we connect to the server. Now we have one shot to say things, and we have to speak the right language. And we learn that the language is HTTP, and this is what it's going to look like. So we said get with a space /hello space HTTP/1.1, and then we give it a new line, host colon scala.io, and then we end it with another new line. So if you type exactly that with the spaces and new line intact into your computer's Telnet terminal, you probably get something like this back from the server. So this time, the server understood our request, right? Like it knows that we want to perform a GET request on the path /hello, and we're using the protocol HTTP version 1.1, and the host is scala.io. And the response that we got from the server was, hey, yes, I understand what you're saying. I understood it. It's cool. So like that's the first line, right? HTTP/1.1, like I'm responding to you with the same protocol that you're speaking. 200 is the status code of the response. And in this case, 200 stands for OK, which is conveniently also in the protocol. So you know, like that was a successful request. And the server also included a bunch of metadata called headers, HTTP headers, right? So it tells you the content type I'm returning is a plain text document. It has 11 bytes in it, and this is the date where the date associated with the request, and then at the bottom, that's the content of the response. So in this case, we made a simple HTTP GET request to /hello, and the server returned the text hello space world. Cool. So that's the text we render from the Rails controller. That's pretty cool. And as you can see, HTTP is a plain text protocol, which means that you can literally type it on your keyboard, right? Like, and you can read it, you can understand it. That's nice because it's easy for humans to understand, to learn, and to debug these things. So the next time you see something like this, you will have a better understanding of what's going on. And what else? So HTTP, yeah, as you can see, it's a structured language. It provides a structured way for the web server and the web browser to ask for things and send metadata and headers and so on and so forth. So that's HTTP. Oh, and by the way, here is a side note. Just as we said, opening a connection to the server is kind of like picking up your phone and dialing phone number. And that is a pretty good analogy because just like your phone, like your old school phone line, your connection to the server in this case is unencrypted. So that means the requests, like literally the text you see on the screen goes through a lot of routers where it like goes through the Wi-Fi here at Unbounds, and then it goes through the router in the room next door, and then it goes to the basement, goes through Telus router, goes through Amazon's router, goes through Heroku's router, and everyone in between has a chance to basically eavesdrop on your connection and look at what you're talking, what you're saying to the server and what the server is saying to you, right? So in this case, we're just requesting hello world, so maybe no big deal, but maybe you're talking to a bank, you're like talking to the CRA and you're looking at your tax return, and you might not want someone else to be able to see the content of your requests and responses, right? So that's where HTTP, so this is HTTP. In order to avoid the problem of having a plain text protocol that everyone can see along the way, we can just encrypt the content of our requests and responses. That way, the same content still flow through all the routers along the way, but because the message is encrypted, to them, it just looks like gibberish because they don't have the key to decrypt it, right? So that's the thing that I just described is HTTPS, stands for HTTP, HTTP Hypertext Transfer Protocol, but secured, like the S makes it secure. And so that's the unrelated side note, right? So, but that kind of begs the question because if you think about it, if you have to open a connection to a server and you want to encrypt your requests, the server on the other end have to have a way to decrypt it, right? So to encrypt and decrypt things, you need to use basically a key to both of you have to have the same key in order to encrypt it and decrypt it. So how do you agree on which key to use in the first place, right? Like, because the underlying problem is like anything you say from the beginning is visible to everyone. So it's kind of a tricky problem for you and the server to agree on the key to use for the encryption in the first place. You have to do that securely. Otherwise, like anyone interested could just pick up that key when you're agreeing on the key in the first place, save it off, and then now you have access to all the subsequent conversations. So that's kind of a extra problem to solve. And I don't think we're going to have time to go into that, but so I'm going to leave it for you to look it up tonight maybe, but just keep that in the back of your mind. So we talk about DNS. DNS is the thing that your computer used to translate Scala.io into the IP address. We talk about HTTP, which is the plain text protocol here for your computer to ask for the things you want from the server, and the same thing that's used by the server to give the content to your browser. So that's the first part. But now we got further, but we still, like, remember the original question is the code you wrote in the controller that renders hello world, that's in Ruby. So we still don't know how we know how the browser communicate to with the server, I guess, but we still don't know where, like, who in the server is calling your Ruby code, like who is calling your controller code, right? So we still need to keep digging. So, okay. So yes, so the next question we need to answer is how does the server generate this response that we see at the bottom? Like, and first of all, the question to ask is like, what is the server that's running on the other end? Like, right, so we have a connection here. On one end, we know that's the browser, so that's not very mysterious. But on the other hand, is the server. But which server? What is the server? What kind of server are we talking about? So that's the web server that we're talking about, and it basically really just means it is a server that listens on port 80 usually and understand this HTTP protocol that we just described here. Some examples of web servers, popular web servers are Apache, Nginx, Lite, Unicorn, Puma, Passenger, or even WebBrick from the Ruby standard library. Some of these are written in C, C++, some of these are written in Ruby, but they basically have they have the same job, which is they have to parse the plain text HTTP protocol that we saw earlier, turn that into a request, figure out what to do with it, and then generate the text, plain text response that we saw on the previous slide. So for simple requests like serving static assets, you can easily just configure your web server to do that for you. So for example, let's say we're using, let's say we want to tell the server, hey, like whenever someone navigates to /assets, /anything, please go to var my app /public/assets and look for the file that they asked for. If the file is found, just serve it to them. If the file is not found, please send them a 404 not found response, and also like throw in gzip compression, caching, all the usual stuff. And so that's what we want to tell the web server to do. And let's say, depending on the web server that you're using, you have different ways to configure it out, right? So let's say we're using Nginx, and Nginx is a pretty popular web server that you can use. It has this config file format. But basically, this is just a translation of what we said on the previous slide into the Nginx configuration format that it understands, right? So here we're saying, when someone send or get request for, or someone send any request for the /assets path, right? Like go to the folder on disk and look for the file that they asked for, and you get the full behavior for free, but with a few lines, you can just add caching and compression, gzip, that kind of stuff for free. So this is pretty nice, right? Like, so if you have this configuration file in your Nginx web server and you have your kitten.jpg in that assets folder, then that's basically all you need to do, right? Like when you go to skylight.io /assets/kitten.jpg, your browser will send a GET request for /assets/kitten.jpg, and your server is going to go to find that file and then send the appropriate response. But sometimes you might want to do something more complex, right? So for example, let's say you want to tell the web server, hey, when someone goes to /blog, can you please go to the database and find the 10 most recent blog posts, and then throw in a header, throw in a footer, throw in an F bar, and also like maybe show some comments and also make it look pretty and return all that, right? So if you have to use the same Nginx configuration language that we saw on the previous slide, to instruct the server to do it, it gets a little bit out of hand, right? Like that's not really something that you can easily express in the same kind of Nginx DSL that we saw on the previous slide. But no problem, because as we know, that's what Rails is for, right? Rails' job is to make that kind of stuff, like building a block should only take 15 minutes, as you know. So really what we want to tell the web server is, instead of telling the web server to do all of that, we really just want to tell the web server, hey, like when you get a complex request like that, you know what, don't worry about it, just hand it off to Rails and Rails will take care of it. So that's what we want to configure Nginx to do for us, but how is the web server, Nginx or otherwise, how is that going to communicate with Rails, right? Like we have this server that parses the HTTP request into something that understood, but like it needs to hand it off to Rails somehow. And so the next question to ask is, how does the web server talk to Rails? So in Ruby, there are a couple of ways you can, like there are many ways you can imagine this communication between the server and Rails can be handled for. So here are some examples of what you could do. So on the top left-hand side, maybe Rails can register a block with the server, right? So hypothetically, let's say server is Nginx, so like basically saying, hey, Nginx, on every time there's a request, please call this block, and then you're gonna pass in the request and the response object, and I'm gonna look at the request object and look at what's in it. Maybe request.path tells me which path you're looking at, and request.headers might contain a hash with all the HTTP headers, and I'm gonna do response.status equals 200 to tell you that it was okay. And I'm gonna do response.body equals hello world for the content I want to send back to you. So that's one way to do it. Or alternatively, maybe the server can call a method on your app. Maybe it will call, let's say my app is the app that the Rails app that you wrote. Like maybe it can call a method called handle request or something, and it can pass in the method, pass request headers and stuff like that. And your app, or Rails in this case, is responsible for returning a response object somehow. Or another way to do it is you can go really minimal and just the server can just run Rails as a script and then pass in the relevant stuff as n variables, and Rails just uses send it out to communicate back to the server. That's another way to do it. So, and at the end of the day, it doesn't really matter which of these you use. The thing that is important is that we agree on one of these ways for your web server to communicate with Rails. And in fact, it will be nice if there are a lot of, as we saw on a few slides ago, there are a lot of web servers out there. And these days, there are also a lot of Ruby web frameworks out there, right? There's Rails, there's Sinatra, but there's also Grape and like a bunch of other things. It will be great if you don't have to rewrite the glue code that glues the web server to the web framework many times, once for each web server, web framework combination. So like it would be really nice if we can agree on a simple convention that all the web servers can implement and all the web framework can implement. And with that, you can just kind of plug them in. So that's why Rec was born. So Rec's job is to present a unified API for web servers to communicate with web frameworks and vice versa. So by implementing the Rec protocol, the web servers only have to implement a single adapter for all Ruby web frameworks, and likewise, the Ruby web frameworks, Rails, Sinatra, all of them can just implement this one Ruby protocol, and they can immediately be ran on any of the web servers. So the job of the Rec protocol is a couple of things. So first of all, the web server needs to have a way to notify the web framework that, hey, I have a request for you to handle. It needs to be able to communicate the details of the request, like the path, the headers, and all of that. And on the flip side, the framework need a way to communicate back to the web server, hey, I handled the request, this is the status code, these are headers, this is a body, and so on. So abstractly, that's the job of the RAG protocol. And in order to keep the protocol simple and make it easy to implement this protocol in all sort of web server and web framework, RAG basically picked the simplest possible way to communicate these information between the two sides. So it notifies when the web server need to, like when a web server receives an HTTP request, it will communicate that as a method call. So we'll call method on your web framework, and as part of the method call, we'll pass in some parameters in the method call that includes things like the path and the headers, and your web server is your web framework, in this case Rails, can simply just return a response as part of the method call. So this is what it looks like in practice, right? So imagine we're inside the Nginx RAG adapter, right? So previously we received the HTTP request from the network and we parsed it into a hash, right? Like so. The hash has this just a simple Ruby hash with the path and other HTTP headers inside the hash, and it is just gonna do, and in this case, app is like your Rails app, right? So it's just gonna do, it's just gonna invoke a method called call, confusingly, on Rails, and it's gonna pass in those details about the request in the parameter. And Rails will look at those and process a request and return an array with 3 things in it. The first thing is the status code. The second is a hash of response headers. And the last one is the body. You might, so the status code is pretty straightforward. It's just a number, just an integer in Ruby. The headers is, again, a hash. That's not super surprising also, but you might be a little bit surprised that the body is an array. And that is probably some details that we can't get into, but usually you can just return an array with a single string in it, but for some more complicated case, it's advantageous to be able to return an iterable, like an enumerator, in a thing that responds to .each, which is what the array is. So for streaming responses, it is good to have that, but in most cases, you can just return, like you can just wrap the string in an array and it will just work. So here, so this is the whole RAG protocol. You can see it doesn't need to require anything, or like it's not, there's no special classes that you need to subclass from. There's no, like everything is just plain old Ruby. It's just using hashes, strings, numbers, and method calls to accomplish that. So Rails is responsible for implementing a method called .call and knows how to turn that env hash into the responses. So where is that? So actually, before we dig into how Rails does it, given that it is just plain Ruby, maybe we can just try implementing this ourselves. So let's try that. So here we made a class. Again, we're not subclassing from anything special. It's just a Ruby, plain old Ruby class. It has one single instance method called call. It takes the env. You can actually call this whatever you want, but the convention is called that hash env. Anyway, this web server is going to call you with a hash with a bunch of things in it, and you're responsible for returning an array with the 3 things that we talked about. So this is our very, very minimal rec aware application that we wrote. So that's cool. In order to run this, we can, there's a convention called config.ru that's similar to the nginx config format, right? Like this is a configuration format that most rec web server understands. It happens to be a Ruby DSL, but really it's just configuration, right? So in this case, all we're doing is requiring that app file that we wrote, and we just tell the server to run our app. So that's all. And rack comes with a utility called rackup, so you can, in the same directory, you can just run rackup. It will read the config.ru file, and then it will now run a very simple web server that delegates to this app that we wrote. And finally, if we go to the browser, HTTP localhost 9292/hello, we will reach our app, and then we will have returned hello world to the browser. So that's how you write a rack app directly without using any frameworks. That's pretty cool. And on the other hand, if we go to /wet, it will also go through the rack up web server that we are running at the bottom, and it will go to that app that we wrote. And it's going to go through the conditional. It's going to see that the path info is not /hello, so it returns a full for not found, which is what we're seeing here. So that's how you implement a web app with rack without a framework. So now let's say we want to do a little bit more, right? Like, what if we want to support going to localhost 9292/ directly and have that redirect to /hello? And that's how you're going to do it. We just edit a if branch at the top, right? So if the path is /, then we're just going to do a 301 redirect to the location /hello, and that's going to go back to the browser. The browser going to see the redirect, and it's going to make a separate second request to /hello, and everything is going to work as expected. So maybe so that works. I'm not going to show it to you, but you can believe me that it works. However, as you can imagine, if we keep expanding the capabilities of our web app, then this function is going to get really, really long, right? Like you're going to have many, many if-else branches. So, and also redirect is a pretty common functionality. Maybe you want to extract that into a more reusable abstraction somehow. Right? So we're going to do that. So instead of making our app handle that, we made another class at the top called a redirect or a redirector, whatever you want to call it. We are going to pass our app into it so that the only thing it does in the call method there is that if the path info is equal to where we want to redirect from, we're going to return the 301 redirect to where we want to send you to. Otherwise, we're just going to delegate to whatever app that we're passed. That way, we have a very modular setup where we can have one class focus on handling the redirects or like redirect or redirects, and then we can keep our like main app functionality in its own class and not have to worry about those kind of details. So, and finally, this is how we're gonna configure it in our web server, right? So we're gonna instantiate the redirect class at the top, but we're gonna pass in an instance of hello world at the bottom so that when we request /, it will short circuit the logic and redirect you to /hello. Otherwise, it's going to delegate to the hello world instance that we passed in. So that works. Again, I don't have slides for it, but you can trust me that this works. But you can see that the nesting is getting a little bit weird here. And because this pattern is so common, the rack up DSL has a nicer way for you to write it, which is this. So instead of saying run redirect.new with the thing passed into it, the pattern is you will probably chain up a bunch of these things that we call middleware. The redirects thing that we wrote is an example of that. It basically does something with the request, and some of the time it might not know how to handle that request, and it will delegate to the next thing in the chain. And that's what a rack middleware is. And this is how you can chain a bunch of them up together. So with that simple pattern that we saw here on the top left-hand corner of the screen, we can compose up a pretty complicated app pretty quickly, right? Like, so these middleware just comes with the rect gem out of the box. So all we're doing is, like, we want to use a bunch of middleware, and then we're going to insert our redirect middleware. And then finally, if none of them handle the request, we're going to go to our hello world app. So with those extra 4 lines, we have added gzip compression, support HTTP head requests, conditional get with an etag, which is used for caching. So now with that, after the first time the browser goes to /hello, it's not, the next time when you refresh the page, is not even gonna hit your hello world anymore, because the browser would have cached the response. So that's pretty cool. And you can imagine how this middleware pattern that we talked about allows you to write some pretty complicated stuff. So finally, it's time to get back into Rails. So we set rack is the protocol that a web application is, or web framework should implement in order to be, in order to participate in the web server and web framework handoff. So here it is. If you look at your Rails app, you'll probably see a config.ru file in your repo, and this is probably what it looks like. So as we learned, the way this config.ru configuration DSL works is that you pass a rack app to run, right? So presumably Rails.application is a rack application, but let's just, don't take my word for it. Let's just actually test it out. So what you can do is you can run Rails console, which you probably used before. And from here, you can, like, we know that a rack application has one simple interface, which is it supports a method called call. And if you pass in the right hash to it, it should be able to handle that. So let's try that. So here we first build up a fake request, right? So we know we need request method, path info, that kind of stuff. And then we are just gonna call Rails.application.call with that hash that we created. So what do you think would happen? Well, first of all, here we're building this env object by hand. Like I have it in there just so you can remember that this is not a any kind of special object. It's just a plain Ruby hash, but you have to have the right keys in there. However, figuring out what keys are the right keys to have in there is pretty tricky. So rack comes with a utility for building that hash called rack : mock request.m4, which you can just pass a URL to, and it will return that hash object. Again, this is not doing anything special. It's just building a plain Ruby hash with string keys for you. So with that, we can call Rails.application and call with that env object, and you start to see some pretty familiar output here that you usually see in your console. But the important thing is Rails return an array with the 3 things we expect from a rack protocol. The first thing is the status, which is an integer. This next headers is a Ruby hash with the keys in there. And finally, body, again, for reasons, it's an array, so you have to join it. But if you do that, you will see that it actually did give you the response that you expect. So that's pretty cool. We know Rails.application is a method that Rails implemented that return a rack app. So, but then if you look at config.ru, you will see like there's only one line in it, but we learned that there are two things you can put in your config.ru file. Like one of them is the run declaration, which gives you the app. But then there's also the use statement, which is what you use to set up your middlewares. So does Rails not use middlewares because we don't see anything in there? Well, no, it turns out, in fact, there's a Rails command that you can run. If you run bin Rails middleware, it will show you exactly the middleware that Rails uses in the same configuration file format. It turns out that it is pretty common for your gems or other dependency to want to add or remove middlewares. Skylight, for example, does that, right? Like when you put gem Skylight in your gem file, we want to insert a middleware so that we can wrap around your entire request and measure how long it takes, right? So if you have to edit your config.ru file like after you install Skylight, that would probably suck a little bit, like, right? Like, so the setup instruction, instead of saying just install Skylight gem into your app, we'll have to say, well, first install gem Skylight into your gem file and then bundle install and then go to your config.ru file and require Skylight and then say use Skylight : middleware. That's okay, but it's not the kind of, that's not the kind of convention over configuration that you're used to with Rails, right? So what Rails does is it internally has the concept of a middleware stack that allows gems or plugins to easily manipulate that, and Rails.application simply take all of the middleware you have in your app and collapse them down into a single rack app for you. So, and so instead of going to your config.ru, if you want to add or remove middleware, you usually, in Rails, conventionally, you go to do that in your config/application.rb, and Rails provide a slightly nicer API for manipulating the middleware stack. So for example, on the last slide, we see that there is a middleware called action dispatch cookies, which is nice, but if you're implementing an API endpoint like a JSON API server, maybe you don't need that. So this is how you can add or remove middlewares from your app. So that's it. So we talked about rack, we talked about middlewares, and we talked about how your gems can add extra middleware to your Rails app, but there's still one more thing. Like we know that the one last question is where is our app, right? So we know that use is for adding middleware and run is for the app. So presumably the thing at the bottom, blog : application.routes is the app. So again, you don't have to just take my word for it. We can actually try it. So why don't we go to the Rails console? Again, we'll do rack : mock request, build the env, and then we'll call log : application.routes that call with that hash. So the same thing happens. So we know that, oh, like this blog : application or whatever your name is, your app is called : application.routes. That's the app that you have that like without all the this is how you get your app with all the middlewares. So what does this app, like blog : application.routes, what does this rack app do exactly? Well, it is built by Rails, and its job is basically to look at the URL, like in this case, /post/1, and figure out which controller action to dispatch it to. Now, if you are curious about how Rails takes, so that app more or less just came from your routes declaration, right? So when you do Rails application to routes.draw, you're basically setting up Rails to turn those URLs into your controller actions for you. Ultimately, this resource DSL expands to something like this, right? Like you're basically telling Rails when you go to get /post, go to the post controller and call the index action and so on and so forth. So if you follow the Rails code in like the routes.draw method, you can keep digging. Eventually, you will notice that this line here basically expands to post controller dot action. Yes, so this line eventually, I'm going to skip over some steps here, but eventually that expands to post controller dot action with the symbol index. So what is that? Well, that's an abbreviated version of the code, but you can see that the main thing here is like the main thing we're looking at is the top, right? Like so it returns a lambda that takes a thing called env, and it does a bunch, instantiate your controller, right? So that the third line in the lambda basically instantiate your controller, pass in a request and response, and it calls .process action with the name of the action, and then it turns, like it returns an array of some kind. So you might or might not know this, but a lambda in Ruby is a kind of object, and this kind of object have a special method on it called .call. So well, surprise, so the action method on a controller actually returns a recap. So like the env here is the same hash that we're talking about, and you can see that it is probably a recap because you can see that it returns an array, right? So again, you don't have to take my word for it. We can just try that in the console. Oh, actually, I don't have a slide for this for some reason, but you don't have to take my word for it. If you can go to your app, you can open up your console and you can do post controller dot action, and then you pass in the symbol index, and you will get back a recap, and you can use the same way that we saw to call it. So here, there you go. So if you're curious about how Rails takes the URL and find the right controller action to call, my coworker, he gave a talk at RailsConf last year for that called regraphing the mental model of the Rails router. So we're not going to have time for the Rails router specifically today, but check out the talk if you're interested. Okay, so putting everything back together. So we have, again, we have here, my deck got messed up for some reason. Anyway, you can go to the console and try all of that yourself. And so with everything that we have learned, here is a few pro tips or cool tricks that you can try with everything we learned today. So first of all, did you know that you can, in fact, in addition to the usual controller resource stuff, you can actually, in your Rails router, you can actually pass a rec app to it. So in this case, remember many slides ago, we wrote a simple class called hello world, right? So you can actually tell Rails, if you go to /hello, please route it to that rec app. So that's pretty cool. And in fact, we know that a lambda is also a thing that supports .call, so we can actually just have an inline rec app here. And that's more or less how, like if you use the redirect method in your Rails router, that's basically what it's doing. It's basically just creating a rec app under the hood and then just returning it there. So yep, that's basically how redirect works in Rails. And finally, you can also just mount any web app in a Rails router. The difference between this and the first line is that the first line specifically say when you go to /hello with like if you do get request to /hello, it will route it to this web app. But in the bottom here, we're saying if you do any kind of request to /sidekick/ anything, it will go to a rack app called sidekick::web. So this way you can mix and match any other Ruby web framework. So maybe you have a Sinatra app, and this is how you can mount a Sinatra app inside Rails. You might even be able to mount another Rails app inside your Rails app. Right? That's basically how Rails engines work, and everything goes through the rack protocol. So I think that's probably it. So now the one last thing is you can instead of writing your resource thing, you can just, with what you learned today, you can just expand your router declarations to use a controller.action method. And this is basically more or less what Rails does under the hood. I wouldn't necessarily recommend you write this in your routes.rb. First of all, it's pretty verbose. And also, you don't get a lot of the benefits of Rails, like auto reload in your development mode, right? Like if you hard code the post controller, then when you start up the web server, it's whatever code you have in there. But if you use the string, Rails is able to reload your controller file every time a request come in development. So, but that being said, it's pretty cool to know how this works under the hood. It knows that post controller.action just give you a rack app, and Rails application just give you a rack app, and that's how everything ties together. So now this is the original thing, right? Like, so we originally set out to ask, when you go to scala.io/hello, locals 3000/hello, how does it get to here? So now we have answered that question, right? Like we know everything in between your browser to up to this point. But now you're probably wondering, how does Rails turn render plain hello world or a template you have into the response? That is indeed a very good question, but unfortunately, I ran out of time for it. So maybe next year I'll come back to do a talk on the life cycle of HTTP response. But now we have covered the life cycle of HTTP requests. But anyway, I think that is, let me check about more slides here. Yep, that is about it. Oh, I have one more example. So as I said earlier, we have a product called Skylight, and it basically, now you can understand how Skylight works, right? Like we insert a middleware at the top of your middleware stack so that all your requests go through us, and we basically start a timer whenever the requests come in, and when the requests come out, we stop the timer, and in between, we also instrument all the things that's happening inside requests. That's here, right? So that's the basics of how Skylight works. Now you might be able to understand that more. It just so happens that we are also hiring. So if you enjoyed this talk, you enjoyed digging into how the framework works under the hood and write code that goes into other people's app and instrument them, and you like the idea of living in Portland, you can go to scala.io, and there's a link there, and you please do apply. But other than that, I think that's all I have got. So thank you very much for sacrificing your summer evening to sit here and listen to me speak. But I hope you find that useful and interesting. Thank you very much.
Great, thanks a lot, Godfrey. I think we have time for one or two questions. So if anyone has any questions, feel free to shoot them over. One question.
Thanks. I'm just wondering, is there any differentiation to be made between a web server and application server? Like I see those two and I get really confused kind of whether it's interchangeable, or there is a fundamental difference?
I think depends on who is using those words in what context. In this presentation, like I think the distinction I draw is the web server is the thing that takes the raw plain text HTTP protocol and turn it like and parse that and figure out what to do with it. And the web application is the thing that doesn't have to I guess the distinction is like your web server is a thing that literally listens for HTTP requests on the network. So when you run telnet skylight idle space 80, that's the web server it's hitting. It talks using raw socket and raw plain text HTTP. The application server is, in this case, it's like the Ruby server that takes the rack server that takes the rack app that takes pre-processed like hashes and return arrays and stuff like that. But it's not necessarily a very useful distinction in like day to day, but when you're looking at through the microscope, it's sort of helpful to have the words to distinguish between them. But yeah. Don't look it up on Wikipedia. Wikipedia will probably disagree with me, but that's for the context of this talk. That's how I use those words.
Cool. Got time for one more question? Anybody? Yeah.
So when I thanks for the talk, Godfrey. It was really great. Thank you. My question is, when I spam something like Puma, it's running a bunch of threads.
Right.
Is Rack going to run one and spawn off a thread, or is there one Rack server listening on each particular thread?
Right. So that's kind of up to Puma, basically. Like as we saw, Rack is not actually anything. Rack is really just the convention of like you have an object that responds to .call that is expected to take the hash and expected to return an array. So as far as Rack goes, it probably doesn't care. In the case of Puma, I believe what it does is, I actually don't know if Puma runs multiple HTTP servers listeners, but I think what it does is it basically spawns multiple threads, and each of the thread is responsible, like each of the thread can handle up to one HTTP request at the same time. So like when your HTTP request hits Puma, it internally parses the HTTP headers and everything, and like internally it has a pool of threads that I can dispatch to. It basically just find one that's not currently processing anything and passes on the HTTP request, like the hash and everything, like to that thread. And when that thread is ready to respond, it takes the response and turn that back into the wire format HTTP response. So as far as Rack goes, it doesn't care, but that's yeah, it's Puma is under hood using the Rack protocol, but that's about it, or at least that's how I understood it.
Nice. Awesome. Thanks very much, Godfrey.
Thank you, everyone.